I'm going to start doing 1 to 2 word problems in their homework packets per week. That might be a little bit more challenging, but to get them to think a little bit deeper. My first piece of advice is most of these problems are more than one step, so to read them a couple of times, at least 2 or 3 times to make sure you kind of have an idea what you're doing. I would always read them once and then kind of go back and pick piece by piece what I need to do next. So let's read this one together. Connor is buying tickets to a concert. The concert he and his friends want to see costs $4.75 per ticket. Connor has $26 total. What is the greatest number of tickets Connor can buy? So we got to think of what we're trying to figure out. We're trying to figure out what's the greatest number of tickets he can buy. And he only has $26, it says. So, how many tickets can he buy if he has this much money and it's $4.75 per ticket? There is many different ways you can solve this problem. I'm going to try to show 3 ways that I think that you might come across. But again, if you come to the answer in your own way and it makes sense and you can show us how you got there, that's fine as well. First thing I'm going to think of is I know he has $26 and it's $4.75 per ticket. So I'm going to start counting up by 4.75s to see how many 4.75s I can have to get to 26. So it's kind of like an addition problem. So if I did, start right here, $4.75. That equals 1 ticket. I put a 1 there because that's how many tickets that's worth. And if I do $4.75 more, this will give us 2 tickets so far. I'm going to add those together, which gives us $9.50. So currently, with $9.50, we have 2 tickets. We'll add $4.75 more. And then that's going to be another ticket, which means that's 3 altogether. 1, 2, and then there's another $4.75. That's 3. And it's 5. This is 12. Carry my 1. That gives us 14. So now we're at $14.25. $4.75 more because we have $26 total. So we're going to get to 26. Can't go over it, though, because we don't have more than $26. And we do this again. We have that. Carry the 1. And that. Carry my 1. 9. Now we're at $19. And that was the 4th ticket we bought, $4.75. Do buy another ticket, $4.75. That would be the 5th ticket we could possibly buy. 5, 7, 9 plus 4 is 3. Carry my 1 is going to be 2. So that's $23.75. So we bought 5 tickets. Now, remember, $26 is what we have all together. If I add another $4.75 on here, that'd be 6 tickets. And there's my 10, carry my 1, 15, carry my 1 again. And that gives us 8 and 2. So if I bought 6 tickets, it's going to cost $28.50. But I only have $26. So I don't have enough for 6 tickets. So I only have enough for 5 tickets. Because 5 tickets cost us this $23.75. So I have to get rid of that 6 because I can't do it. I'm going to have some extra money left over, but obviously I just can't buy another ticket. So the most amount of tickets he could buy would be 5 without going over that $26 that he has currently in his pocket. You could also do the opposite and start with 26 and start taking away $4.75 each time. That'd be 1 ticket he took away, and then that would borrow from over here, 10. Make that a 10. It's 5, 2, 1, 2. So that means he bought 1 ticket and he still has $21.25 too. So you can count down by $4.75 to get there. I think more kids are usually better at adding up, so that's why I think this way is probably easier to do. That's fine too. Another thing you could possibly do is think that $4.75 is close to 5. So you can kind of guess and check yourself. So $4.75 is close to $5 per ticket. So if I did the math, well, if I did $5 per ticket times 5 tickets, it'd be $25. So I'm guessing the answer is probably close to 5 tickets. So I could just do $4.75 5 times to figure out if that answer is about close. 5 times 5 is 5, carry my 2. 5 times 5 is 25, carry my 5, carry my 2. 5 times 7 is 35, plus 2 is 37, so my 7. Carry my 3. My decimal. 5 times 4 is 20. Plus 3 is 23. And we can see, hey, 5 tickets just about work perfectly. So those are 3 ways you could solve the problem. If you can see the multiplication side of it by guessing and checking, like, hey, 475 is close to 5, that might be the quickest way. This way is probably the most natural way for most of our brains to think currently. And this way, if you like the subtraction part, would be a way for you. But either way, he could get 5 tickets with $26. And I want to go a little bit slower because it's only 2 problems. I know it's going to be about a probably 10 to 15 minute video. But for 2 problems, I want to just give you different ways you can solve this so it makes sense to you. The next one. Jeff wants to buy a bike that costs $150. He has already saved $102. He earns $8 each hour working as a lifeguard and saves all of it for the bike. How many more hours does Jeff need to work in order to have enough money to buy the bike? This is a problem I'm definitely going to have to read 3 times. So let me go one more time and then figure out how much money he has right now. So Jeff wants to buy a bike that costs $150. He has saved $102. So I know for sure the bike costs $150. He saved $102. So I can figure out how much more he needs to get the bike by subtracting these to find the difference. So if I did 150 minus 102, I could figure out how much more he needs to get the bike. But that wasn't what we were looking for, so I'm going to read it again to make sure I know what we're looking for. So he earns $8 each hour working as a lifeguard and saves all of it for the bike. How many more hours does Jeff need to work in order to have enough money to buy the bike? So we're trying to figure out how many more hours does Jeff need to work to get the bike. So the first thing I want to think about is how much more money he needs to save up to get the bike. That's going to be the 150 minus 102. So if I did 150 minus 102, that's going to tell us how much more he needs to get the bike. Can't do 0 minus 2, so I borrow from here. 10 minus 2 is 8. 4 minus 0 is 4. 1 minus 1 is 0. Put a 0, that's fine. But so he needs $48 more. So now that I know he needs $48 more to get the bike, here's where I'm going to read it a 3rd time. And I know this is a little extra work, but sometimes you need to read a problem 2 or 3 times, do a step per read, and you might be able to get the whole answer much more efficiently than just guessing and getting it wrong. So now I know he needs $48 more for the bike. So let's read it again. Jeff wants to buy a bike that costs $150. He has already saved $102. So we need $48 more. We figured that out already. He earns $8 each hour working as a lifeguard and saves all of it for the bike. How many more hours does Jeff need to work in order to have enough money to buy the bike? So he needs $48 more, and he makes $8 per hour as a lifeguard. So if he worked 8 hours, if he worked 1 hour, that would give him $8. So 1 hour, $8. If he worked 2 hours, that would give him $16. It's almost a multiplication problem. You might see that. If he worked 3 hours, give him $24. If he worked 4 hours, that would give him $32. And remember, we want to see how many hours does he need to work to make up that difference of $48 he still has not paid, or he still has not had to save for the $150 bike. So if he worked 5 hours, that would give him $40. And if he worked 6 hours, that would give him $48. Cool. So he needs $48 more to buy that bike, and $48 will come when he works 6 hours. So the answer to that question, because we're looking at the very bottom question at the very, very end, the 4th time I'll read it just to make sure. How many more hours does Jeff need to work in order to have enough money to buy the bike? Well, 6 more hours. If he works 6 hours, he'll have that $48 he needs to make up that difference, and he can buy the bike. So the answer to this problem would be $6. If you were paying attention, I read the whole problem once. I read the top to make sure I knew that the difference. I read it again to make sure I had it correctly, and then I needed to make my 8. How many hours would it take him if he did $8? And I read my question. I mean, realistically, I read this problem 3 or 4 times throughout this section. You may, or not say may, you should be reading it at least 2, 3, or 4 times. And I did it 4. As an adult, it took me 4 times to make sure I had the answer correctly. So as a kid, it probably would take you 4 times as well. I hope this helps. These are the two problems. They are important. If you need help, watch this video more than one time. Ask your parent. And if you're still confused, ask me or a peer who you feel like might understand this better in school next week. All right. Thank you very much. Bye.